Hey everybody, let's try to solve this machine. So we're looking for the reactions for this member over here. Okay. Well, it's actually only asking for the reactions right here, but okay, so what do you do for a machine? Break it apart. Okay, so there's this piece over here, and then this shaft over here, and then this one over here, and then this piece here, this piece over here, and then the scoop. Okay, so there we go. And then it's kind of giving us a hint. Members B, C, and DH can be treated as two force members. So BC is right here. So for example, it could look like this. And then DH is this one over here, this shaft. So it's like that. I mean, it could also be this way, right? So you just pick one or the other. And then if the answer is positive or negative, determines which way the arrow was supposed to go. Okay, so this was here, and this was here. So we know that these two are equal and opposite. Okay, so I'm just going to get rid of this to save space. Now this shaft over here is connected here and here. So for sure, these are equal and opposite. So I'm going to erase this just to save some space and less clutter. Okay, and then the scoop. Okay, let's see, there's the downward force, which is given right here, right? Okay, so this is given right here. That's 1800 newtons. Okay, and then there's this pin over here. So I'll just draw like that. And then what else? Okay, and then for this member over here, okay, since I drew this here, before I forget, I'll draw it over here. Let me label these. So J coordinates like this. So this is pin J, so X, Y. So this has got to be equal and opposite. Okay, and then let me name this something. I'll just call this B. This is B, and then over here, that's D. So this has got to be D over here. Okay, and then right here, pin K, that's right here, which is also right here. Then I have to draw it equal and opposite, right? Okay, and then what's missing right here? Okay. So already when I look at the picture, there's no way that's what it looks like, because look at the picture over here. There should be another shaft like this connected to this pin, and look, there's this other hydraulic right here. Like, so there's another pin over here. So that's physically impossible that it looks like this, because this is actually connected to the rest of the excavator. And just in reality, when I look at it, there's got to be some couple like this over here. There has to be. So maybe this particular question is only asking about over here. So what's happening here is sort of a mystery. So I'm just gonna, let's just ignore that part because it's physically impossible. Okay. However, this particular problem, it's only asking about member C, D, K right here. Since it's calling it C, I'm going to call this C. Okay, right, so it's only asking about this one, really. And when I look at it, look, see how there's 1, 2, 3, 4 unknowns, 5, 6. 6 unknowns. And we have these two free body diagrams, which means we can write 6 equations. So we don't need this one. We don't need to write equations for this member of the machine, which works out since we don't have the information over here. Okay, so let's do that. Let me move these. Actually, I'm just going to delete this for less clutter, because I need the numbers up here in the picture. Okay, so we have these two free body diagrams, and you can write 3 equations for this one, 3 equations for this one. Okay, so in the x direction, let's see. So we have the information about this angle right here. Okay, so maybe you have to zoom in on the picture, but you see point C, let me write up here where I have more space, this point C, point D, and then point K. Here to here is 260, and then here to here is 260, but then point B is kind of over here, and here to here is 180, which means the leftovers right here has got to be 80, right? And then here to here is 320. So that means we know the angle. Right here, this angle right here, I'll call it theta C. Right, so arctangent of opposite over adjacent. Okay, so we know that angle. And then what else? This angle over here with D. So we need that angle. Once we got all the angles, then we're good, right? We got all the geometry. Okay, so this angle over here, I'll call it theta D. Okay, so for this angle D, let's see, there's D over here, and then there's H over here. And then here to here is, how far? 1120. And then here to here, this is point H, is 100. Okay, so arctangent of opposite over adjacent. Okay, so we got theta D. And then I think that's all the geometry we need as far as angles. Okay. All right. Oh, and then same angle over here. Theta C. Okay, so x direction minus D cosine theta D plus C cosine theta C plus kx. Okay, and then y direction, ky minus d sine theta d minus c sine theta c equals 0. Now let's sum torque about somewhere clever. So this problem is asking about the reactions at point K. So that's what we're actually trying to solve for. So why don't I sum torque? So I don't want to sum torque about K because I want those answers. So it's either about D or about C. And I have C over here. So I'm going to sum torque about point D. Okay, so about point D, here to here is 260 millimeters times kx. And then from here to here, from D to C is 260. Okay, so then you see C, it looks like this, right? And then here to here is 260. But then if I decompose C into this component and this component doesn't provide any torque, only this one, right? So what's this component? C cosine theta. So that means minus 260 c cosine theta. Okay, and then that's everything. All right, now let's go to this free body diagram. So x direction, jx minus c cosine theta c. That's it. Y direction, c sine theta minus F, which is 1800 newtons, plus Jy. All right, now let's sum torque about somewhere. So I don't want to deal with these two unknowns. So I'm going to sum torque about point J. Okay, so there's torque from F. So the lever arm is right here, 200 millimeters, minus 200 millimeters times F, which was 1800 newtons. And then you see the lever arm from here to here. That is how much? 260 plus 180. Right here. So 440, right? So plus 440 millimeters. And then you see this force right here. If we split it into components, this component doesn't provide any torque, only this one. Right? So then it's 440 millimeters times only this component, which is c cosine theta. Okay, let me point out the unknowns. C. Okay, here, here, here. Okay, so what do we do? Right here, you can solve for C right there. Once you have C, you can plug it in right here, and you have Jy. You can plug it in right here, you have Jx. So we know all three of these. Okay, now you take C, and you plug it in right here, and now you know Kx. Let me get rid of my circles, and I'll do them one at a time. Okay, you already know C. Plug it in this equation, solve for Kx. So now we know Kx, and we already know C. Right, and then now look at this equation. There's only one unknown left, D. Okay, so now you know D, which is right here. And now look at this equation, only one unknown left, Ky. Okay, so now we know all 6 unknowns, Kx, Ky, C, D, Jx, Jy. This particular problem was only asking for right, the reactions at K, but we know all of them. Okay, so keep on practicing with frames and machines. I think these are the most tedious and require the most practice. So let me know if you have questions. See you on the next video.